morning. Just a quick check-in, and then I'm going to let you guys go. But for today, okay, we do have that verse, Romans 15:4. So distant learners, again, you can take that. Please try not to cheat. I know it's right there in front of you possibly, but do your best just to pull out a blank sheet of paper and you're writing that verse from memory. You can review it some before you write it. Write that. You can send me a picture. I'll put in the grades today. Make sure you keep that hard copy and turn that in again tomorrow. And you can pick up anything that we'll need for next week tomorrow as well. So now begin that. Also, you can send me pictures of the booklet, but because it's a little longer, it'd probably just be best when you turn it in tomorrow, when you can come by and pick up everything. Just turn that in because then I'll look it over and give you a grade for that. But there is no class or lesson today, so what we're going to do is you distant learners will do that. Send me the pictures, keep hard copies, turn it in tomorrow with everything else for the last 2 weeks. And then students in the classroom, I'll be down there a little bit. You'll take your quiz, and while you're taking your quiz, have your student booklet out, the worksheets, and I'll be looking through those as you're taking your quiz. I'll be down there in a couple minutes. Again, if you have any questions, distant learners, just text or email or My Schools Works me real quick. I'll try to check it as best as I can if you need anything. And then students in the classroom study before I get down there. You'll pull out a blank sheet of paper and you'll write your quiz. Hope you guys do well. Let's have a good day today and hope you do well on the quiz. We'll see you soon. Good morning, class. How's everyone doing today? Hope everything in Bible went well. Just for those who maybe tuned in a little later and missed it, I got Christian Halsey's, but for Bible we just did the verse quiz. You had that verse quiz today, so if you want to pull out a separate sheet of paper and sometime in your spare time today with nothing out, and just write your name on it, class and date, and then send me that. I can get that graded and put in today for that Bible verse, Romans 15:4. And then we reviewed for the quiz. If you have any questions on that, distant learners, feel free to contact me. I'll give you as much information as I can. But you just don't want to study the notes that we had. I believe that was it. Oh, and the student worksheet you can turn in tomorrow. You can't send pictures, but I know it'd be a lot more work with that because there's a few more pages than just one, so you can just turn that in. I can grade that tomorrow when you come to pick up the rest of your stuff for next week. But today we're just picking up where we left off yesterday, and we'll keep on moving. We did not have homework yesterday, so we're all good there. Today we're going to be getting through some stuff you guys probably have already read, but we'll pick up where we left off yesterday, get through that, have some homework tonight. We do have a quiz in history tomorrow, so I'll try to review through the stream, so distant learners, you can get some review sheet on that as well. And if I haven't sent you that quiz already, I'll send you that quiz today or tomorrow morning. And then next week, if you want to plan it now, either Monday or Tuesday, just be ready for it. We're going to recite it today in class, but we have a quiz over the Star-Spangled Banner. We should already know it, being Americans, but we do have a quiz over the Star-Spangled Banner. It's just going to be a blank sheet of paper, basically, a quiz sheet. You're going to be writing out the Star-Spangled Banner. So that'll be next week, either Monday or Tuesday. Start looking that over if you want to write that down in your lesson plans. But we have quiz tomorrow over page 15 to 24. So everything we've covered in the notes as up to now, all the way to probably all the way to socialism, but we'll review that later at the end of class. We'll have homework tonight, study for quiz tonight, but we'll get through the lesson today and see what we have left. Quiz tomorrow, and then Star-Spangled Banner. We'll recite that today in class, and then we'll have a quiz on that next week. So just be ready for that. If you have any questions, again, communication is key, certainly for distant learners. As I can talk to students here, certainly after class, but it's sometimes a little hard to communicate everything to you guys. So we'll do our best to work with you, even if your stuff might get turned in a little later. Just communication's key. If there's no communication, then things are not going to work. But we're going to leave right off we're going to start right where we left off yesterday. Let me pop that up real quick. You said sometimes I block the notes, so I'm going to drag myself down right here. And we'll just do that. All right, yesterday we were talking about communism. Sorry, went a little too far. We're talking about communism and how all that stuff works with totalitarians. It was funny. I actually watched a movie last night while working on some schoolwork. I'm sure you've seen it, The Hunchback of Notre Dame, or Notre Dame, depending how you say it. Right, the Disney movie, anime movie. We were just going through some old original Disney movies, and so that one came up, and I liked that one. So we're watching that, and the master in that, right, the main villain of the story, I forget his name. It starts with like an F, I believe. I can't really remember it very well. But I was telling him, I was like, man, we're talking about how with tyrants and dictators, right, and evil leaders that had this totalitarian mindset of, hey, we're doing it my way, no matter the consequence or sacrifices of others. And this guy wanted to capture this gypsy and burn her or kill her to make it a public scene to show his power. And just because he was so he felt embarrassed by her, he felt like she diminished, and gypsies as a whole diminished his power, He thought they were evil. So his whole purpose and agenda, rather than being a good leader and upkeeping the whole city of Notre Dame, he was out for his own personal gain and beliefs and trying to push that agenda no matter the sacrifices. In that time, he burnt civilians, bystanders, just because they didn't know any information, and that's when it clicked in my mind. I was like, yeah, we're talking about that kind of in history. But just a fun fact, a good movie, a nice oldie movie to watch. But communism, we started talking about that yesterday, but we're going to move with that. We're talking about communism to a thing called Marxism and Leninism. This is another name for communism. So it's pretty much the same thing, just another name. It's because of these two people. It's named for two of its most infamous theorists. We have Karl Marx and Nikolai Lenin. Okay, that's why, again, it's Marxism and Leninism, because Karl Marx and Nikolai Lenin. It's pretty much communism, just named something different because of two different people. Marx formulated the basic ideas of communism. That's why they also called communism the Marxism and Leninism, because Marx formulated the basic ideas of communism. And then number 50, Lenin added his own ideas and was the first to put communism into practice on a large scale. A large scale. This Marxism and Leninism has been called the master plan of hell because of its satanic character. Whittaker Chambers, one of America's most knowledgeable and authorities on communism, explained it like this. So this Marxism, Leninism, or communism, this considered master plan of hell, he explained it like this. The communist vision is the vision of man without God. It is the vision of man's mind displacing God as the creative intelligence of the world. So again, it's taking that whole mindset kind of humanism and taking it to an extreme of there is no God, there is no creator or creative intelligence of the world. So I will just have my own vision of man without God. Next, what is the difference between communism and traditional dictatorship, right? So we talked about dictators, people who ruled from outside of that country or state, right? Communism takes this dictatorship idea or philosophy to a whole new level. So differences between communism and traditional dictatorship. Dictatorships usually end with the dictator's death, while communism is a self-system that is self-perpetuating. So it's not just one leader dictatorship, right? They'll have their time to lead, they'll run it how they want to run, they die, and then their ideas and philosophies pretty much kind of just pass away, right? It goes back to maybe another dictator or another leader's philosophy or ideas, whereas communism is a system. So it doesn't matter who's in place of leadership, it's a system that is self-perpetuating. So the ideas of this system, not by a man, will last for a long time, as we see it's still being practiced in different countries, sadly. Another difference is dictatorship, traditional one, attains a satisfying limit of power, right? So they have a lot of power, dictators, but there is a limit of it, right? They don't have supreme power. It's not an overall rule. It's one man trying to convince a nation. Whereas communism is never satisfied. It is never satisfied, must endlessly increase its power. So communism is always pushing its philosophy, always pushing ideas, growing and growing and growing, ingraining people more and more and more. Whereas a dictator, right, he can only go so far. He only can convince people to go so far. Next, you have traditional dictatorship is generally careful not to alienate the people and allow some degree of personal liberty, right? So this dictator pushes their agenda, but they don't want to push too much to where the people he's leading kicks them out or they kill him or throw him out. You know what I'm saying? Whereas communism claims the totality of a person's life and allows no freedom. So communism's main focus is basically building a somewhat robotic system where you have to follow everything. There is no leeway. There is no freedom. You don't have a little choice. You have to do exactly what the system calls for. The goal of communism is not equality or government by the people, like a democracy or something like that, ruled by the people. But a goal of communism is not equality of government by the people. It is the concentration of power among a small elite group of bureaucrats who control the wealth and resources of the nation, while the majority of the population work like slaves to support the state. Okay, so we see this, probably one of the highest forms of this type of communism that we just read about would be what country in the world? There's only one that I can, well, there's a few, but there's one that really comes to mind, and it'd be North Korea, right? The goal of communism is not equality of government by the people, but it is the concentration of power along a small elite group, or this leader and his elite group, who control the wealth and resource of the nation while the majority of the population work like slaves to support the state. Communism will tolerate no rivals. Okay, so a lot of times in the communistic countries, right, there is no freedom of religion. They can't have any other religion because they don't want other rivals. There's no other forms of government or ideas because they want no rivals. Okay, so between 1917 and 1991, over 100 million people in the Soviet Union alone were murdered by the means of forced starvation and wholesale execution. Because maybe it was people that weren't following the rules, they were trying to do their own thing a little bit, right? Or maybe they were starving and they were just like, I'm sick of it, I'm not doing what you're telling me to do anymore. And that led to either execution, or they would take the food supply away, or starvation. Since 1949, China has executed over 40 million Chinese citizens because of their philosophy of communism. Another one, over 140 million human beings in the Soviet Union and Red China alone have been murdered by Marxist totalitarianism that is equal to the population of the U.S. in 1940. Just a sad, sobering thought, thinking of all these people that were murdered by this false and terrible way of government and evil dictatorship, that all these people were killed through that. How thankful we should be, right, that our country is not communistic. Although we joke around that sometimes it seems like some parts of our government are trying to go socialistic or communistic, but thankfully we are not. Communism is a negative system which denies God and God's word and the true nature and destiny of man. Okay, it denies all, remember, it denies all of that of a creator or of someone being over them. Sorry, I had a quick yawn. In God's word, obviously, because they don't want it to be their rule book of life, right? If they believe in God and the Bible, then they're like, oh, well, I'm subject to, I need to listen and obey the Bible, right? So they think, oh, if I discredit that there is no God and I deny him and his word, and then the true destiny of man, how we're supposed to live, can be my own way rather than God's way. Here's some quotes by some people, certainly communistic people, right? Our goal, so this is Marx, the guy we just talked about with Marxism, Karl Marx. Our goal is to destroy capitalism and dethrone God. So with the system that they made, right, they're trying, it's kind of, if you guys know in Bible, right, the Tower of Babel, people were trying to become God, right? They thought they could build a building so high that they could be as high as God, so they could be like or as God. So this is a government run with the idea of our goal is to destroy capitalism and dethrone God in the influence of his word. Engels, another man under this idea, he considered God is man. Okay, so he's trying to bring God down to man, thinking we're equal, we're the same. Okay? Basically saying there is no real God. There is no great creator, all-powerful, all-knowing God. We're all the same. God is man, which is false. And then we have Vladimir Lenin or Nikolai Lenin. Religion, so he's talking religion is, and in perspective is understood, religion is the opiate of the people. So saying it's a drug, it's a false belief. It's an opiate of the people. Then Mao Zedong, or Zedong, however you say it, don't laugh at me trying to say it, just trying to. He says, our God is none other than the masses of the Chinese people. Right? China is a very populated country, so this dictator or leader's belief under communism is our God is none other than the masses of the Chinese people, saying our numbers is our God. We have so many people, that is our God. Again, referring back to that humanistic belief of, man, we are our own God. We have no higher leading or creator, someone over us that we're supposed to believe in. Communism denies creation. It asserts that the only reality is matter and motion, and that everything in the world, including thought, will, and feeling, can be explained only in terms of material. This is called materialism. Okay, so again, communism denies creation. They deny the idea that God created everything from nothing, right? With the thought or words, he spoke it into existence, right? They deny that belief. Rather, they think that everything is explained only through terms of material or things that are tangible, right? Well, if that were true, that's sad, because then there would be no salvation. We couldn't trust in our Jesus Christ our Lord to be our Savior, that he died on the cross, was buried, and rose again, because that's all through faith. The Bible tells us it is by faith. Right? We believe by faith, and we're saved by faith, not by works. And so if this were true, then all of that would be discredited, which is what they're trying to do. They're discrediting the being of God and the idea of God and everything that comes with it of God and the Bible. So they're saying everything is only explained by tangible, by, again, making God or making man their own God. Again, this Karl Marx guy, Marx wanted to dedicate Das Kapital to Charles Darwin, if you've heard of him, whose works popularized evolutionary concepts and attempted to give evolutionary theory a scientific basis. Okay, if you've heard of Charles Darwin, smart guy, but obviously very wrong beliefs and theories in a sense of creation. Next note is communists deny the fall of man and state that they intend to further the course of evolution by remaking man's nature and man's society. Again, this is communists trying to deny any existence of a God, deny the fall of man, that we were perfect in sin, and state and that they intend to further the course of evolution by remaking man's nature and man's society. Trying to change what God created. They're trying to say, oh, since God is not creator, there is no God, then we can just make it our own. We can change it however we want. Communism denies good and evil. Okay, denies good or evil. So that means it denies God and it denies sin, which is wrong. No God means no law, right? If there is no God or no God that's all powerful that we're supposed to submit and obey, right? No God, no law. We can do whatever we want as man. So no law means no absolute standards of good and evil or right or wrong. The ends justifies the means. Okay, so basically saying there is no God, there is no final law, there is no Bible, right? If there is no Bible, well then what's to tell man what is good or evil? Right? Someone that might have a twisted mind might think something, well, that's okay because I'm twisted anyways, right? It's okay in my eyes, so I can murder whoever I want. right? So see the problem, what would happen with this communistic belief because they take away God in the Bible. And it's sad because we're not quite seeing this, but we're seeing crazy things happen in our country. And if you really think about it, it's extremely sad. Communism also denies redemption. Communism denies redemption. Man has no means of personal salvation. Again, they're denying God, they're denying the Bible, they're denying the gospel, like we talk about in the Bible. With this communistic belief, they're denying all of that. What's the point of life then? The point of life to them is to live to satisfy themselves, whether it's good or bad, right? No morals. No morals at all, and no belief of anything. And it would be a pointless and dark life. And it's going to lead to a pointless and dark afterlife as well. 61. Communism denies the humanity of man. Denies the humanity of man. It reduces man to the level of a higher animal or a complex machine. Okay, so you have these higher people, right? The elite, the people that run this communistic thing, right, that works for them. But then you have everyone that's under that is not even considered man. They're just like an animal, a horse. They're just something to use, a tool, right? That's what communism makes the life of man mean. The normal man, we're just a tool, another animal on the lot, right? Do my bidding, and if not, I'll kill you. That's basically, a lot of times how you do treat farm animals, right? Obviously not in all farms, but say you have something like where you need the ox or the horse to do a job. And if it's not able to do the job or it's not able to live, right, then a lot of times people just kill them or get rid of them some way. And that's how communism is. It's like we're going to use all we can. We're going to use you as the tool or animal you are. And then when you can't be used, we're going to dispose of you. Okay? And this is the belief of communism. 62. Communism denies the nuclear family, the traditional unit of husband, wife, and children. Communists believe that children belong to the state. Again, taking away the nature that God gave to man, because they're taking away God in the Bible. They're taking away the beliefs that are built in the Bible about husband, love your wives, one man to one woman. Children, obey your parents. They're taking away all that. That children are to obey and belong to the state. I can do whatever I want with the children. And if you can do whatever you want with the children, guess what? That means you're building whatever future you want for that country. Think about it. If you have power and access to all children, and you have the right to anything, not the parents, then you get to build the future. So if you take all the kids right now, in 20 years, who's the adults? 30 years. It's the children, right? And they're the ones that's going to run the nation at that time. So if they control them, they control the nation or country. Communists believe that if they can destroy marriage, the home and family, life in the nations of the free world, destroy and family life in the nations of the free world, they will encounter little opposition in subverting and conquering those nations from within. Next, number 63, communism denies private property and individual responsibility. Without these freedoms, people are motivated to merely get by and to consume all they can get. Just checking what time class gets out. Sorry, I forget. We'll stop right there. We'll get through, so not quite as far as I wanted. Not quite as far as I wanted to get, but we'll just stop right there for now. Give me 1 second. I want to go over a few more things before I go over the quiz. Give me 1 second. Let's see. All right, so just a few more things I want to go over. They're not in the slides, but things we might have talked about or mentioned. But socialism, right? We have modern dictatorship, particularly totalitarian regimes, often maintain control over the people through socialism. If you didn't have that in your notes, write that down. Socialism is not a form of government per se, but it is a system of government controlled over the economy of a nation. Socialism. Okay, that's what we're going to leave off in the notes. We'll finish the slides tomorrow. And we're going to talk about the Christians and how and with what Christians are supposed to do with government. Maybe a few more things on communism, but we'll get through that. But we'll talk about Christians' responsibility with government. But homework tonight. So we have that quiz tomorrow, quiz 2 tomorrow. We're about to review for that right now. But also, let's see. Yes, so you're going to be reading. Sorry, I might change it up because remember we missed that day, so we're a little off the schedule. Yeah, we'll do quiz tomorrow, and for homework, because we're going to teach this tomorrow, I'm going to change it a little bit. Okay, so I'm going to split it up half and half, so you're only doing half of what homework would have been. You're going to read pages, so write this down. Read pages 34, so starting chapter 3, page 34, 35, page 34, 35, and 36. So read pages 34 through 36. And then do, on page 39, section 1 review, do questions 1 through 5. Some of those questions may be on page 37 and 38, so just do those as well. But so read pages 34 through 36, do page 39, 1 through 5. So distant learners, the lesson plan is going to be a little different. So you could just do the lesson plan if you want, because we're going to be ending up doing all that anyways, if that makes that easier. But for today, you guys read pages 34 through 36, do 1 through 5, and then we'll review for the quiz now. If you have any questions, you can let me know once I get down there. Distant learners, you can ask. But distant learners, again, because just how the system works, it's communication. You have the lesson plan, so you might be ahead, whether it's in the reading or homework, but that's okay. We'll do our best. You'll have everything turned in. We'll get grades in. You might be a little ahead, but that's okay. You guys just follow the lesson plans. If you have the lesson plans, just follow those. You might be ahead in work somewhere, but that is okay. Just do your best. Follow the lesson plans. Students in class, you can just do as I said, and now we'll study for the quiz. Okay, so you're going to want to pull out a separate sheet of paper. Again, remember quizzes are, I give you almost everything exactly what's on the quiz. So pull out a separate sheet of paper. We'll review it real quick. I'll get you chapter 3 notes either tomorrow or on Monday once we start that. But here we go. Have a sheet of paper out. We're going to go through this review real quick. And then before class ends, I wanted to go through the Star Spangled Banner at least once today. We'll go through it tomorrow as well. We'll probably go through it Monday and have then the quiz on Tuesday over that. All right, we have short answer and matching on this quiz, 5 of each. So here's some questions or some of the notes if you want to highlight it in your notes. But here's some terms you're going to want to know. You're going to want to know what capital punishment is. what capital punishment is. It was the first foundational civil ordinance. You're going to want to know what capital punishment is. One question is, according to William Blackstone, what are the two foundations for law? Okay, so two foundations for law. We talked about it, right? We talked about how with law there's kind of two types of laws, right? There's revealed law, so that's one of them, revealed law, which is revealed by who? Revealed by God. Revealed law is revealed from God or the Bible. And then you have natural law, which is law that's given from God for government or for man. So you have revealed law and natural law. You don't want to know what the Decalogue is. Decalogue is basically just another term or reference to the Ten Commandments. Decalogue is a reference or is the Ten Commandments. You're also going to know, the question is, what according to Charles Schumann is the price of socialism? What according to Charles Schumann is the price of socialism? So what does socialism cost? Right? It costs freedom. Freedom is what it costs. So you could write socialism costs freedom. And then you have some matching 6 through 10. Some terms you're going to want to know with those. So if you want to write down these terms so you can study them. You don't want to know what absolute monarchy is. Absolute monarchy. You don't want to know what autocracy is. So autocracy. Autocracy is... You don't want to know what constitutional monarchy is. So you absolute monarchy, constitutional monarchy, autocracy, constitutional monarchy. Another term is fascism. You don't want to know what fascism is. Fascism is the totalitarian dictatorship in which all power is vested in one ruler. Right? So everything put dictatorship all invested in one ruler is fascism. Like with Adolf Hitler. You don't know what theocracy is. So the difference between autocracy and theocracy. Theocracy means rule by God, right? It means rule by God. Autocracy, so theocracy means rule by God. Autocracy means what? To rule by oneself. To rule by oneself. You don't want to know what totalitarian dictatorship is. What totalitarian dictatorship is. So the difference between fascism and totalitarian dictatorship. Fascism is the totalitarian dictatorship in which all power is vested in one ruler. Totalitarian dictatorship is the ruler exercises absolute control over the people and seeks to control all aspects of society through coercion. Okay, so those are all the terms you want to know for matching. Hopefully you have that all down. If you have any questions, contact me. Let me know. That is everything you need to know for the quiz tomorrow. Distant learners, I'll try to get that quiz to you today. If I didn't already send it last night, I think I might have sent it last night, so you might have already have it. But if not, I'll get that to you tonight or tomorrow morning so you can take that. Again, you don't want to come by tomorrow and pick up everything for next week. Tomorrow, I'll try to have everything ready. And then everything for these past 2 weeks, you can bring in the hard copies, even if I've already sent a picture in. But let's go through the Star Spangled Banner one time. It is somewhere in your books, but you should know it by heart. But I'm going to read it. You can follow along. Those in the classroom and at home, I want you to say it out loud. Saying something out loud helps you memorize something, so say it out loud as we read it. We're not singing it. I'm not singing it for you. I'm sorry. So I'll read it. Okay. The punctuation doesn't have to be perfect when you're writing it, but the words do. Each word will be points off. So here it goes. We have, oh, say can you see, by the dawn's early light, what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars, through the perilous fight, o'er the ramparts we watched, were so gallantly streaming, and the rocket's red glare, and the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free and the home of the brave. Okay, again, Obviously, we should know that. You can sing it in your head while you're writing it. The 2 words you might want to look over, whether you're looking up on the internet. Okay, so you have in the 4th little sentence and the last sentence, it's not O-R, it's or, like O''er. So make sure you have that, like or the ramparts. If you put O-R, I might take it, but just to let you know. You don't want to know that again by next week. If you don't know it already, next week we'll have a quiz on that. Tomorrow we have the quiz we just reviewed. You have the homework assignment. If you have any questions, let me know. I'll do the best to help you. All right, have a good one.
All right, welcome to chemistry. We're going to get right into, he moved this. We're going to get right into it. We're dealing with 2.2. So help me, I just crashed the whole thing. You couldn't just leave it alone. Okay, hopefully that'll work. Okay. I have preset scenes for a reason. All right, anyway, moving on. Properties. Okay, so 2.2. Sorry, I should probably discuss the section first. We're going to be doing a couple things today, so go ahead and get out your textbooks, get out your supplements and your textbook. We are on page 23. Page 23 of your textbook. We're starting right at 2.2, and we're on page 12 of your supplement. And so we're going to talk about two main things today, the properties and changes of matter, first of all, and then we're going to talk about subatomic particles. We're going to actually start getting into the real nitty-gritty of chemistry. So that way when we're doing chemistry later, we kind of know at least on some level what's happening, okay, in the background. So that's what we're going to be working on. Let's get right into it. First and foremost, properties are descriptive, identifying, and distinguishing characteristics of matter. Okay, basically they are what identify or help us identify a substance as a substance. For example, water is near tasteless, or rather, we're used to the taste of water. I don't know that tasteless would necessarily be the correct word, but water is tasteless, it's clear, it dissolves quite a few things. Those are all properties of water. And so they help us identify what's actually happening. Okay, so we have the properties of matter, and they're in two categories. The first one is physical properties. Helps if you're on the right program. Physical properties, these include color, odor, density, hardness, solubility, taste, state, boiling point, and melting point. These are all physical properties because they're physical things about the chemical, okay, or about the substance, rather, is the term we're going to use. Okay, and so these are all the physical properties, okay, and these are important and they're necessary and they're really what kind of give us our first clue. Just quick note, I don't recommend tasting chemicals to find out what they are. It's a bad plan. Poison's a thing. Just throwing that out there. All right. But then there's chemical properties. These describe how matter reacts to change into other chemically different substances having different properties. So chemical properties of water would include that it's both an acid and a base. Okay. A chemical property of water would be that it can dissolve salt. These are all different things that chemically occur. And so, I'm sorry, that's a physical change. I forgot, dissolving is a physical change. But anyway, water is both an acid and a base. As a result, it's both a byproduct and can react with acid and bases, albeit very tiny amount, but that is a chemical property of it. Now, physical changes are changes in the physical appearance of matter that do not change the identity or chemical composition of a substance. This is typically reversible by physical processes. For example, I mentioned dissolving accidentally earlier. Dissolving is a physical change. I can dissolve salt into water. It physically mixes with the water, but it doesn't chemically combine with the water. And so we can undo that physically. Okay, the main, or the easiest, I should say, way to undo dissolving would be to boil off the water as water vapor, and then you have salt. Okay, so that would be an example of physical change. It takes a physical action to undo. Now, chemical changes are changes in which a substance becomes a different substance with different composition and properties. It can be reversible by chemical processes, but it does not have to be. Okay, so for an example of this, this would be sodium and chlorine coming together to form salt. Well, it's very hard to pull them back apart and get sodium and chlorine, okay, back out. If it's even possible, I honestly don't know. But we're moving on. Chemical changes are indicated by the following: the formation of a gas. Now, so does boiling. Okay, so we're talking about formation of a new gas. Okay, formation of what's called a precipitate. This is an undissolvable or insoluble substance. Undissolvable, insoluble, same thing. Okay, insoluble just means undissolvable in water. Okay, so precipitate is what we call that because it precipitates out of the solution. The liberation or absorption of energy, okay, in other words, it gets hot or cold, okay? You're going to understand we have to use a lot of technical terms because here's the thing, cold doesn't exist. There's less heat, that's it. There's levels of heat. So anyway, so we say the liberation or absorption of energy, okay? And then finally, a distinct change in color. If all of a sudden you have a green thing in a beaker and all of a sudden it turns purple, something probably just changed pretty drastically. All right, so those are chemical changes. Now we can separate mixtures in a couple different ways. The first way is distillation. This is boiling and then condensing a liquid for purification. Oh, sweet, my videos aren't working. Give me a second. Hopefully I typed all that correctly. Hey, look at that. And we're in chapter 2. And I want figure 212. All right, so simple distillation, we'll notice you're boiling this liquid off here. Okay, and as we do this, okay, then that liquid can be purified and sent down here into this other beaker, okay? So that's what's happening. So we're just measuring temperature, and we can separate out two substances this way. This is actually how we could capture water out of the saltwater mixture if we wanted both the salt and water to remain. Normally we just would want maybe the salt back, and so we'll just let the water boil off. But if we want to collect the water too, this is how we would do this. So this is what we call simple distillation. But there does exist a fractional distillation. Okay, so in this case, you'll notice we have these different beads and things here. And what this does is this traps in a whole different chemical. And so this is useful if you have like 3 things dissolved together that you need to separate out. More details are in your book on that. Let's see here. And this helps especially separate things with boiling points that are very close together. These will kind of trap the one that's less volatile. I'm trying to make sure I get the right wording. The one that's more volatile will go ahead and go right through the beads and come out to the beaker. So fractional distillation can be used if we need, if the boiling points are very similar. Obviously salt and water, that wouldn't be necessary for the simple reason that salt and water have very different boiling points. All right, so that's how that works there. All right, but the other way we can separate it is through chromatography. I should not have closed that tab. Chromatography is the separation of complex mixtures. This was originally done by color, and we can actually see that in this diagram here, not this one, this one. Normally I just click links in the thing, but let's say we had a piece of paper, we drew a line across it, and we hung it inside a beaker. Well, the paper will diffuse it, and what we'll see is that as this diffusion occurs, we can see the different chemicals separating out into the paper, and we can see those different colors. So this is one of the simplest forms, and other chemicals that will remain less soluble will remain where they are in the beaker. But then the solvent is evaporated, and we can see it and analyze it. This is how it was early done. Now we use gas chromatography or column chromatography in modern science, and it's a little bit more precise than this. All right, so that's how we can separate mixtures. But now let's get into some more interesting stuff, subatomic particles. Okay, now just real quick so we all know what I'm talking about, subatomic particles are just particles which make up atoms. I really wish I could show you this. All right, subatomic particles, particles which make up atoms. And there's a whole history of this. And I'm going to bring out some of that as I teach. I highly recommend, if you don't watch any of the other Crash Course Chemistry videos in here, watch this one because he does a great job of explaining the history of atomic chemistry. Okay, and it's very fascinating. But we're going to get right to page 26. Okay, and for the longest time, atoms were thought to be indivisible. We talked about that in Dalton's theory. And then all of a sudden in the mid-1900s, we were like, oh, they are divisible. Oh, I mean, maybe we can get some power out of it at least. And that's kind of what happened. So obviously there was a lot of math involved, a lot of scientific work, and I'm not trying to undermine it, but it was like, oh, that kind of blew that theory right out the water, okay? Or out the desert, rather. All right, moving on. So the first one that was discovered, or the first subatomic particle was, hold on. I want to get the right name for the right person. Humphrey Davy and Michael Faraday. These two gentlemen used electricity to decompose chemical compounds in the early 1800s. And so this fact suggested that electrical forces held elements together in compounds. And they didn't realize they just discovered electrons and things like that. They just realized, these things, if we throw electricity through this chemical, it'll decompose it. Okay, like water, for example. Well, on the basis of Faraday's work and Davy's work, Irish physicist George Stoney proposed that units of electrical charge or negatively charged particles were associated with atoms. He named these proposed particles electrons from the Greek electron, meaning amber. Okay, all he really did was change the K to a C. And this is a substance known to become electrically charged when rubbed with silk. And so we actually get our name electron from the Greek for the word amber. That's what it comes from, because you could easily get an electric charge on amber by just rubbing it on silk. Okay, really easy stuff. Well, not long after scientists figured out that, hey, there's electricity in these atoms, okay, that they had been studying electrons for years without realizing it. Since 1859, scientists had known that if two electrical leads are sealed some distance apart inside a glass tube from which all air had been removed, there's your definition for electrons. Strange effects occur when the cathode or electrodes are connected to a source of high voltage electricity. Invisible rays emanate from the cathode, which is the negatively charged electrical lead or electrode, and travel toward the anode, or the positive electrode. Now, on batteries, those terms are backwards. It depends on which way electrons are flowing. The cathode would attract the positive. The anode would attract the negative. Just bear with me there. Okay, so for right now, that's the way that we need to deal with this. Any other air remaining, or any other gas remaining in the tube begins to glow with an eerie glow, and the color of the glow depends on the gas in the tube. Well, okay, I seriously need to stop closing this tab. I'll just move it to the other screen next time. Let's see here. This is 2:15. All right. Now, we know them today as CRTs, or cathode ray tube televisions. Actually, you all may not. It depends on how much older technology you've dealt with. So you'll notice here, we can actually create kind of a shadow of an image. And so this is Crookes' version of a cathode ray tube. Nope, I don't need that one yet. All right, so this is, I was wondering if there are more versions animated. So let's see here. So Julius Plucker actually first discovered this principle with the cathode ray tubes. And the mysterious rays were named cathode rays because they emanate from the cathode. Okay. For this reason, a gas discharge tube of this type is also known as a cathode ray tube, or CRT. So if you guys remember the big TVs, not big screen, okay, but the thick TVs, before everything went flat screen or LCD, you had this big, almost like a bulb on the back. Okay, it was almost like a bulb shape. I don't know. See, some people may or may not know this. Let me go over here. I'll just show you guys what I'm talking about, because that's a little easier to describe. Okay, do they have a whole one? All right, well, this is Wikipedia, so I can show this because everything on here is Creative Commons. All right, so this here would be an example of a CRT. You guys, hopefully this vaguely remembers what I'm talking about. These are really heavy. They have glass on the front. It's just weird to me that I have to explain what a CRT is now, because some people honestly don't know, and that's fine. We've moved past them. Well, this is the inside of one, okay? And there's a reason for that distinctive shape that they had, and the glass on the front was really just a landing pad. And I'm oversimplifying greatly here, okay? I'm not really talking about how old TVs work. I'm just saying, but this is how we applied this principle. And so this right here is actually the electron gun. It would actually fire electrons at the glass to excite phosphors coated on that side of the glass. And that's how we created an image. Okay, now I'm not really getting into the deep history of TVs and why we moved away from them, other than they make horrible high-pitched sounds, and seriously, I can't stand being in a room with one anymore until I lose the rest of that part of my hearing. So that's one of those things where it's just we moved on because we developed better technology. But anyway, so that was really how we applied that with that there. So this is dealing with those electrons. So Sir William Crookes designed an improved tube in which the cathode rays missed the anode, and that's what's being shown in this diagram, by the way. The anode is actually down here. Well, the electrons don't have time to curve, so they actually can produce an image. Because electrons move really fast. That's why they don't have time to curve. We'll talk about more of that later. But objects placed in the path of the rays would cast shadows on the end of the tube. Now, Crookes speculated that the cathode rays were actually particles of some sort because they caused the foil target wheel mounted inside one of his tubes to turn when it was struck. He also found that the rays had the same properties regardless of the cathode material. Later, researchers found that the rays could be deflected by magnetic fields, and again, we apply that to televisions. Well, cathode rays puzzled physicists for several years until the English physicist J.J. Thomson demonstrated they are composed of negatively charged particles, the electrons that Stoney had proposed years before. Since any material in the cathode produced the same particles, electrons must be present in all matter. Well, Thomson also determined the ratio of the charge of an electron to its mass in 1897 by experimenting with the deflection of cathode rays in electric and magnetic fields. Thomson could not determine either the mass or the charge separately, but could determine the ratio of charge to mass. Well, in 1909, Robert Millikan actually devised his own experiment. Whoops, wrong one. There we go. In which he used X-rays to knock electrons off atoms in oil droplets and measured how fast the charged droplets fell in the electric field. From this data, he determined the electron's charge, which in turn allowed the electron's mass to be calculated. An electron is an extremely light particle with a mass of only 9.1094 times 10 to the negative 28th grams. That means you're moving that decimal place to the left 28 times. Okay, that's how tiny this number is. Okay, electrons weigh near nothing. Not quite nothing, near nothing. Now, with the discovery of the electron, Dalton's concept of the indivisible atom was proved incorrect. Okay, and this is really what kind of blew everything out of the water. Okay, and questions arose concerning the presence of other subatomic particles. Since atoms are electrically neutral, they must contain positively charged particles to balance the negatively charged electrons. Also, since electrons have very little mass, some other particles must be present to account for the atom's mass. Because the idea was, you know, the atom obviously has mass because they make up all matter. Well, if the electrons don't have it, something has to. Well, in 1886, studies by German physicist Eugen Goldstein. Do I have a picture of him? Nope. Oh, this is the guy who designed the cathode ray tube. You have him to thank for modern television. Julius Plucker. Sir William Crookes is the one who made the better diagram there. J.J. Thomson, this one's actually a very famous physicist. We only mentioned him briefly in this class, but he was, again, the one who proved that they're actually electrons. Millikan is the one who made that oil drop experiment that I was just had on screen. Need to do better at making sure I have all these images while I'm talking about them. But Eugen Goldstein showed that in addition to the negative rays or cathode rays, a CRT produces positive rays that flow in the opposite direction. When holes or canals were made in the cathode, the positive rays, called canal rays, were found to pass through the holes and produce a fluorescent glow at the cathode end of the tube. Further work by German physicist goodness, I want to say it's Wilhelm Wien, but I'm not sure. So I'm pretty sure that's how you pronounce his name. And J.J. Thomson in 1898 led to the discovery of positively charged particles called protons in the canal rays. And so these are positively charged, protons are positively charged subatomic particles about 1,836 times more massive than the electron. So those are still small in comparison, but you'll notice that it's to the negative 24th grams instead of to the negative 28th. Okay, so orders of magnitude bigger. Eventually, the proton was shown by the British physicist Ernest Rutherford to be a component of all matter. Okay, and so these guys are really responsible for a modern understanding of the atom and how all that fits together. And so it became very clear very quickly that atoms had multiple parts. And so the race was on to figure out how that all fit together. Because again, it was thought of that atoms were just spheres and like you would not be able to divide them. And maybe they were shaped like the material they were working with. And that's all they had to go on. Well, now all of a sudden we're finding pieces of atoms. Now what? Okay, so now we got to figure out, okay, well now how does the atom work? And even the theory, or even the diagram you're used to, is probably incorrect. Because we only use that to show an idea of it. All we can do is model it. Okay, so we're going to go through this here. And so we figured out that it must have a nucleus in addition to the electrons. Because the electrons are so easy to knock off, we figured out pretty quick the electrons should probably be outside the nucleus. Well, first of all, let me see, do I find the, oh, I do define the word nucleus later. Well, the first theory we had was the plum pudding model. And again, this was very quickly disproven because we understood that the electrons had to be able to be knocked free easily. This pictured the atom as a sphere of positive charge in which the negative electrons were embedded. And so in other words, instead of separate protons, it's just the whole sphere was positive and that was most of the mass and the electrons were in there, kind of like raisins in a pudding. This was proposed by Thomson. However, there was an experiment that soon disproved this. Okay, and here is an example of that experiment there. Let me go right back to the beginning. So Geiger and Marsden shot a beam through gold metal, gold foil. And they used subatomic bullets to bombard this. And when these ions collided with the gold foil, a few of the ions were reflected back toward the source. And yet some of them passed through. Well, if Thomson's plum pudding model of the atom were correct, reflection of the ions back toward their source would have been as impossible as bouncing a bullet off of a piece of tissue paper. The helium ions should have plowed right through the foil with little, if any, deflection. From the experimental results, Rutherford knew that a new model was needed. He explained his co-workers' results by proposing the existence of a small central nucleus containing virtually all the mass and all the positive charge of the atom. And so this is really what did it, because again, if these were these little full spheres, okay, empty space would let it through, but then it shouldn't be able to bounce back. It should knock the sphere out of the way. Well, the fact that it's being bounced back means it's being repelled. And so clearly their discussion had been wrong. All right, so he created the planetary nuclear model. Oh, here, this is an example of that experiment that they were showing. When they're being deflected, they're actually bouncing off the nuclei or maybe being grabbed by the nuclei. Not necessarily bouncing off, but grabbed through. And, well, occasionally you'll get one that's going to bounce right off and right back to where it came from. And again, should be impossible. So this was his explanation, and this became known as the planetary model. This is also known as the basic nuclear model. You'll notice this is kind of what we're used to seeing with atoms. Well, it's actually incorrect too, but we're going to move on. The planetary nuclear model places a nucleus being orbited by electrons, and this was proposed by Rutherford as a result of this experiment. Now, to kind of give you an idea of the scale we're talking about here, I'm not going to finish this today, am I? What time does this class get out? Oh, I got more time than I thought. Okay, cool. I was thinking 10:40 for some reason. We got until 10:50. All right, so he proposed the nucleus, which is a small central region containing virtually all the mass and positive charge in an atom. And here's the thing, this model is mostly correct. There is a nucleus with all the positive charge in the center of the atom, with all the mass in the center of the atom, and the electrons are outside the atom. That part is all correct. They just don't look like this, and we're going to talk about that here in a minute. Now, to give you an idea of the relative sizes of these things, though, let's say we were able to take an atom, okay, or just the nucleus of an atom. If we were able to make the nucleus of a single atom the size of a tennis ball, okay, and then we took that tennis ball to a football stadium, and we placed it in the dead center on the 50-yard line. And we're talking about like a pro football stadium, not a high school one. The electrons would be like gnats in the stadium, with the tennis ball in the center. That's how much space, empty space is in an atom. Okay, and so that's really what we look at here. Because the diameter of an atom is determined by the volume occupied by the electrons. Okay, well, the electrons spread out so much, yeah, that's the scale. Okay, and that's the size comparison. If the tennis ball were the nucleus, gnats in the stadium would be your electrons. And they are about as predictable, okay? And we'll talk about that more in a little bit. But let's talk about the discovery of the neutron. And this didn't happen right away because electrons were easy. We could easily identify and find negative charges because electrons are freely moving in many metals. Okay, again, another concept we'll talk about later. So that was easy. Then if there was a negative charge, there has to be a positive charge. So that was a logical conclusion to jump to. However, there does exist a particle with no charge at all. And this actually stumped scientists for a while because they would look at these electrons and these protons and they're like, yeah, all that makes sense. Where's the rest of it? Because we could measure how heavy these elements were supposed to be, and we were only getting about half the mass. And we're going, well, then where's the other half? And so the discovery of the proton did not explain the observed masses of atoms. It was speculated that the nucleus contained additional protons plus electrons to make up the discrepancy, and they were kind of right there. We'll talk about that in a minute. But basically the idea was, well, maybe the center has more protons than what we're measuring, and then there's just more electrons in the nucleus that we can't detect because they're in the nucleus. According to this idea, the additional electrons in the nucleus would balance the charge from the additional protons because they could figure out their charges were balanced. Well, in 1920, Rutherford proposed the existence of a neutral particle in the nucleus having a mass approximately equal to that of the proton, or that of a hydrogen atom, which is just a proton. His model taking all three subatomic particles into account is diagrammed in the figure 222, which is on the screen right now. Neutral particles, such as the one Rutherford postulated, would be difficult to detect. Not until 1932 did English physicist Sir James Chadwick conclusively demonstrate the existence of such a particle called the neutron. He determined the mass of the neutron to be 1.675 times 10 to the negative 24th grams, just slightly heavier than the proton. In summary, an atom is mostly empty space. At the center is a small, very dense nucleus containing positively charged protons and uncharged neutrons. The nucleus is surrounded by as many electrons as there are protons in the nucleus. A summary of these three subatomic particles and their properties are given in Table 2.8 on page 29. Now, a lot of times we won't do these blue boxes, but I want you guys to go to page 30 in your text. Page 30 in your text. I do like going through this one just a little bit because we're still learning about subatomic particles, and now we're really looking into the subatomic particles. We have electrons, protons, and neutrons down. Those aren't changing. They're correct. We've proven them. Okay? We're still trying to figure out what makes up those things because our idea that something indivisible exists at the bottom of the rung has kind of been shattered. So we keep trying to break stuff apart. Well, electron, we're pretty sure that's as small as it gets, but who knows? But protons and neutrons, we're pretty sure are made up of different things. Now, everything I'm about to tell you right now is theory. It's a working model. It's not necessarily been 100% proven, although most scientists agree this is basically going to be how it works once everything shakes down. We may have a couple things off, but this is kind of the working model, much like the way the atom was at the beginning, and we refined it over time. And so this still has much room for refinement, but I just want to kind of give you guys an overview. This next bit is only partially testable, okay? As far as like you should know the term, that's basically all I'm looking for. So okay. Murray Gell-Mann, which when I wrote the slideshow, he was still alive. I'm not sure if he still is. But he proposed quark theory in 1964, as did George Zweig. I have no idea if I'm saying that correct. But these two gentlemen proposed quark theory completely independently in 1964. And what quarks are particles which compose protons and neutrons, which are commonly called up and down. There's actually multiple types of quarks and like things in the standard model of physics. But this was confirmed in 1968 at the Stanford Linear Accelerator. Okay, so it's confirmed, we just don't quite have all the pieces correct. Okay, and so we can see a proton formed by quarks and a neutron formed by quarks, and that would imply that I hadn't just closed everything again for some reason. Okay. It's because they're not called that. All right, so this is the quark model of the proton. And so basically this would be a proton, and what's going to happen here is you'll notice that this ends up becoming an entirely positive charge because it's made up of positive and a negative charge. And so what happens is our up quark has a plus 2/3 charge. And so together, this would be 4/3. Well, that's more than one, and we know that a proton has one charge. Well, the down quark, shown by red here, is negative 1/3. So between our 4/3 minus 1/3, well, that's 3/3, or 1. So this becomes our proton. Well, with the neutron, okay, the opposite happens. See, I get two down quarks, which are negative 1/3, and one up quark, which is positive 2/3. And so 2/3 minus 2/3 is 0. And so we get a no charge particle here by neutron. Okay, and so these are the two main types of quark. These are the two that are found in everyday matter. Perhaps that would be the way we would word that. But in addition to that, the standard model of elementary particles has a ton to it. This is non-testable. Calm down. I felt the panic from here across the camera. Okay, this part is non-testable, but I always show it because I want to show you guys exactly how far this theory has spiraled. Okay, and there's no guarantee that these are the bottom particles. Okay, there might be stuff that makes up this stuff. We're talking about extremely tiny particles here. If you thought the electron was small. Okay, so we basically have these three pieces, the up, down, and the electron. Okay, and these would be the three that are really common. Okay, and the up and down are expected to be literally glued together by what we call a gluon. Yeah, scientists had a lot of fun with that name. And so there are many pieces of this that they're still working on. However, we have pretty much confirmed the up and down quarks. We have confirmed electrons, obviously. And so we've confirmed pieces. We just haven't necessarily confirmed all of it. My favorite is the fact that we don't say like magenta, we say anti-green. Because you have anti-red, anti-blue, anti-green instead of cyan, yellow, and magenta. I kind of wish that's what we called the colors, but anyway, moving on. Because cyan is exactly opposite red. But anyway, so don't worry about that too much, but I just wanted to mention that. There's two types of, you know what? Nope, not getting into it. So anyway, if you want to learn more, it's called the Standard Model of Elementary Particles. Beyond the scope of this class, but I know some of you might be interested in it. Wikipedia is your friend. You just can't use them as authoritative research, okay? But it's useful enough to get in a basic understanding of things, okay? So that's the idea there. So that's going to conclude 2.2 and 2.3. Your homework tonight is to do questions 1 through 11 on Chapter 2 on pages 15 through 16 of your supplement. Again, that is questions 1 through 11 on pages 15 and 16 of your supplement. And you're going to submit those via photo on Google Classroom. Please make sure you submit stuff on the assignment. Don't just text it or email it to me. I don't need to be tracking down 100 people's papers, okay? Put it in the assignment. That's why it's there, okay? and that will help me out. Okay, so you guys are just going to take a picture of your work tonight. Normally I like to have it where you guys enter your stuff, but time did not allow that for me today. All right, and then tomorrow we'll start looking at 2.4 and 2.5. If you have questions, feel free to text or email me. Past that, I will see you guys later.
All right, guys, we're back. We are on 1.7 in consumer math, where we talk about annual operating costs for the vehicle that we're looking at purchasing. Remember, the cost of the car is not just the selling price. To know if you can afford a car, you need to figure out annual operating costs, okay? Which includes the sum of all annual expenses, including average annual depreciation and annual interest charge. Okay, operating costs include stuff like fuel, oil changes, tires, any basic repairs that you might need to make on the vehicle. Those are all included in the operating costs of that vehicle. So just because you have a payment of, $250, $300 does not mean that's all you're going to be paying for that car in that particular month. You're also going to be paying insurance. You're going to be paying your fuel, oil changes, and that type of stuff. So in order to figure out operating cost, we're going to look at model problem right here. It says Joe Floyd has a car that originally cost $18,000. His annual depreciation is 13%. He pays 7% interest on the original cost of the car. His annual expenses for repairs, gas, oil, maintenance, fees, and insurance are $1,600. What is his annual operating cost? Find the annual depreciation, multiply the cost by the rate of depreciation. So we did that. We have 13% times 18,000. That gives us $2,340 of depreciation. To find the interest charge, multiply the cost by the interest rate. So we have 17,000 times 18,000, or sorry, 7% times $18,000. That gives us $1,260. And then we're going to take and we're going to add up all of our expenses, so the depreciation, interest, and the operating costs, and we're going to have a total annual operating cost of $5,200. So basically, it's costing him, if we're to break it up throughout the whole year, it's costing him $100 a week to run his vehicle. All right? So that's how we're going to go through. We're going to find annual operating costs. Your homework for tonight is going to be on page 22 and 23. We're going to do problems 1 through 11 odd. 1 through 11 odd. That's your homework for tonight. Coming up next week we're going to start doing speed drills. Next week we're also going to have our second quiz. I believe that's going to be on Tuesday. Wednesday is going to be the first test. That's going to be over all of chapter 1. And then yes, this quiz 2 on Tuesday, we're going to go over, that's going to have, it's going to go over section 1.1 all the way through the whole chapter. And then the test, of course, covers the whole chapter as well. So that's what we're doing next week. Tomorrow, we are doing something a little different. We have these pages in our book called Analytical Skills. Tomorrow, we're going to go over pages 24 and 25, and basically it helps you think through the process of purchasing a vehicle and other areas of life when we go through analytical skills, and you can choose the best answer for you. It's not necessarily the best answer for the individual in the story. So you're going to go through, and we're going to do this tomorrow. And it's just to help you think through critical thinking skills. What's the best for you? All right? So I'll be down in just a couple minutes.
Okay, guys, we're going to get started right into the lesson. Go ahead and pull out your vocab books. Okay, that's better. Go ahead and pull out your vocab books. We're going to go over our homework from 2 nights ago on Tuesday, which was page 10, exercise A and B. We're going to go through those answers. Make sure you guys have them. All right. Check your answers. We will have our quiz in vocab next week. Okay? So make sure you guys are studying those. Today, we're going to go over exercise A and B, and then we're going to look at our word analysis. All right. Letter A, or exercise A. In Ghana, West Africa, pregnant natives carry a fertility fetish on their backs, believing that this practice will cause them to have beautiful children, okay? Fetish is an inanimate object thought to have inherent magical power, so they want to have children, so fetish is the word. Number 2, the influx of tourists provided increased opportunities for the small town entrepreneur. Opportunities is kind of your key word for there, or for that one. Entrepreneur is someone who organizes and manages a business, assuming the risk or profit or loss. We know entrepreneurs to be people who take risks and stuff like that. Obviously, that's in the definition, but we know them to someone who likes opportunities, businesses, things like that. So opportunities is your key word. Entrepreneur is that word. Number 3, a versatile instrument in proficient hands, the violin can produce light, cheerful tones as well as mellow, plaintive ones. Plaintive, that is expressing sorrow or mournful. So, number 4, some reporters will resort to any kind of chicanery to gain entrance to special events and locate strategic positions. Chicanery. Trickery, especially in legal dealings, the use of subterfuge or trickery in debate. Number 5, the plot of the novel was banal. The language trite, the characters nondescript. Banal is kind of like lacking freshness. It's not as, lively, okay? Number 6, the youngest child in the family was piqued when he had to go to bed while the rest of the family stayed up. Pique is to evoke resentment in, to arouse. So he obviously was upset when he had to go to bed. Number 7, the newly rich couple were so verdant that they did not know what a black-tie dinner was. Verdant, green with growing plants or grass, green in color, or they're unripe in knowledge or judgment, unsophisticated. So unsophisticated in that definition is kind of your clue word that they didn't know what a black-tie dinner was. Number 8, the slave trade was a heinous practice. Thousands died during passage across the Atlantic because of starvation and disease. Heinous, hatefully, bad or wicked, abominable. Number 9, the black clouds in the sky denote that there is a storm coming. It's to indicate, that is denote. Number 10, she could not help becoming pensive as she watched the plane fading away in the distance. We know pensive to be, on page 9, thinking deeply or seriously, often of sad or melancholy things. Number 10 is pensive. Number 11, J. Gresham Machen was admirably trenchant in his defense of supernatural Christianity. Trenchant is forceful and effective, keen, penetrating. Number 12, the ruthless king went to any extreme to aggrandize his country. Aggrandize is to exaggerate or to make greater, richer, or more powerful. Exercise B. I'm just going to go down through the list. Nearly a synonym, okay? Number 1, A, 2, C, 3, G, 4, I, 5, H, 6, K, 7, D, 8, J, 9, L, 10, M, 11, E, 12, F. Okay, and then go ahead and do exercise C if you did not for homework tonight. If you have not done it already, go ahead and do exercise C. And that is for your homework, okay? And then make sure you guys are studying your prefixes, your roots, and your suffixes. Those will also be mentioned on the quiz. Next week I'll announce that as soon as I have that. I'll probably announce it tomorrow or Monday, okay? Probably tomorrow. I'll announce it tomorrow when our quiz will be. Okay, so go ahead and put that away. Nope, don't put it away. Go ahead to turn back to your poem. Death Be Not Proud, page 104. Hopefully you guys are studying this. We will have our quiz soon. I will also let you know when that is tomorrow. I think it'll be quiz, let's see, Friday, Thursday. I think our poetry quiz will be on Thursday next week, okay? So study for that. Make sure you guys are memorizing it so that you can fill in the blank. I'll have this one, a fill in the blank one, since we can't recite them orally as a quiz. So make sure you guys are memorizing this, all right? Let's go ahead and start at the top with the title and the author. Ready, begin. Death Be Not Proud, from Holy Sonnets by John Donne. Sorry if I didn't mention. Read this out with me, okay? Death be not proud, though some have called thee mighty and dreadful, for thou art not so. For those whom thou thinkest thou dost overthrow, die not, poor death, nor yet canst thou kill me. From rest and sleep, which but thy pictures be, much pleasure. Then from thee much more must flow, and soonest our best men with thee do go. Rest of their bones and souls' delivery. Thou art slave to fate, chance, kings, and desperate men, and dost with poison, war, and sickness dwell, and poppier charms can make us sleep as well, and better than thy stroke. Why swellest thou then? One short sleep past, we wake eternally, and death shall be no more. Death, thou shalt die. Good job, guys. If you did say it out loud, thank you. All right, be memorizing that for next week's quiz, okay? Take out your literature books. We're going to go over a new era or a new period today. That is the medieval period, okay? The medieval period. Go ahead and turn to page number, page number 13, okay? Just some history for you about the medieval period. So the Norman conquest, okay? So the Anglo-Saxon period came to an end when the last Saxon king died without an heir to the throne. So his kinsman, William, the Duke of Normandy of France, he came and claimed the throne, okay? So the Anglo-Saxons rejected him, but William the Conqueror was determined to rule England. So he sailed to England. Look out on page 13. You can see kind of like a depiction of that. This scene from the Bayeux Tapestry depicts William of Normandy sailing across the English Channel to conquer England. So he sailed to England, conquered it, and he became the king. Okay, so this marks the end of the Anglo-Saxon period, and the medieval period began. This was in 1066. So the Old English period was at a virtual end. Okay, so this conqueror, this battle where he fought England, was known as Norman's Conquest. Then this is where he became known as William the Conqueror. So that's kind of how William became the king of England. But the Normans had powerful influence over the English culture. So they added different elements to English culture. They added refinement. We know France now to be fashionable, and Paris is one of the fashion, capitals of the world. So even back then, they had even more nice culture, okay? Because the Anglo-Saxon culture, they were very barbaric and very like rural, different things like that. That's what the French added to England. One of the most significant results of this conquest was the influence that France had on English literature. So the French language combined with their Germanic language of the Anglo-Saxons formed Middle English, and a lot of the works that were written in the medieval period were, they became translated into Middle English. And if you guys look in your books, you can see that literature written in English was not to be found for 100 years after the Norman invasion. So at this time, a lot of other works that were written in different languages came out. So the Normans came to England and introduced a lot of things to England. They introduced feudalism to England. Many of the English farmers that owned their own land there, when the French came, they conquered the English people. So the dukes and the knights of the French culture became the lords and the ladies of the land, and the Englishmen became serfs or servants that, you know, worked their own land for those nobles, okay? Another thing that was kind of interesting about this was William the Conqueror introduced the census to culture. So he wanted to get an account of everything that in all his realm, everyone that lived in his realm, he wanted to get an account of. So he sent a census, he recorded everything in a book called Doomsday, and much of we know about English culture is actually recorded in this book. So William, he also took control of the church. He appointed church officials. He actually started the Archbishop of Canterbury, which is still the highest official in England. So different things like that. A lot of the culture that William the Conqueror brought to England was what they went from, and we know that the French heavily influenced English culture. So the next thing we'll also see is the age of chivalry. Another thing about the medieval period is that chivalry was the code of conduct set for knights and the nobility of that age and that country of England. This age of chivalry promoted strength, courage, loyalty, courtesy. Chivalry established certain protections for churchmen, peasants, and women, but we kind of see the influence of chivalry when we're going to read through this story or this medieval period time. It's a lot of the works that are written about knights. They're written about, you know, knighthood and chivalry, and authors tended to romanticize this period. A lot of the times we see these knights are there in shining armor and they're coming to rescue somebody, but in reality, knights back then, they kind of sometimes treated their peasants or their serfs with cruelty, and they sometimes and oftentimes were barbaric. So that's kind of what this medieval period is about. Their works were kind of romanticized somewhat, but that's just kind of like a background of the medieval period and how it came to be. It marked the end of the Anglo-Saxon literature period when William the Conqueror came and conquered England, okay? Next, we're going to see that Latin, we said Latin became common, French became common, and then new literary genres emerged. So look on page number 13 that we should be on. You guys can see out of the early courtly literature sprang the Romance, of which the tales of the King Arthur and Sir Gawain and the Green Knight are good examples. Look at that next paragraph. The medieval period was a time when many literary genres were born to be developed in later times. The lyric, as well as the drama, was germinated during the medieval period. Both were brought to maturity during the Elizabethan period. So romance, the lyric, the drama, these literary devices came out during this time, but then they weren't popularized until later on. So in the 14th century, there were a number of individual authors who came to be. One of the very popular authors of the medieval period was Geoffrey Chaucer. And then there's two others, William Langland and John Wycliffe. We all know John Wycliffe. One of the most notable writers, well, the most notable writer of the 15th century was Sir Thomas Malory. And then other events happened in the 15th century during the medieval period where William Caxton, he set up the first printing press in England, and this is when they could, mass produce or produce Canterbury Tales of what Chaucer wrote, and different literature works was able to be printed on into writing, okay? That's just the background of your medieval period. Go ahead and turn to page number 14. Page number 14, we're going to talk about ballads and carols. So if you look at a ballad, a popular ballad is a short narrative folk song which tells of a single, usually tragic event in an objective, unbiased manner. So that's what a ballad is. It's telling a story, it has some rhythm to it, but it's more of tragic things, more sad things, different things like that. A carol, look at the difference between the ballad and the carol. The carol is a popular art form which originated in medieval France. Carols were originally any joyous songs or hymns, but later the term carol became associated with Christmas hymns in particular. The Cherry Tree Carol is an example of an early English folk carol. So ballads are kind of folk songs that are more sad, they're usually tragic, objective, unbiased. It's just the story of a sad happening and a sad incident. And then a carol is a joyous song or hymn, and they usually relate to Christmas or anything religious, okay? So that's the difference between ballads and carols. The first one is a ballad, which is Bonnie Barbara Allen. If you guys look at it, it's just basically talking about how Sir John Graham, he falls in love with Barbara Allen. And in summary, I just want you guys to look at it. It's not super important, but he falls in love with Barbara Allen, and she doesn't love him back, but she doesn't love him back because he insulted her one time. So she is not having it, and then once she rejects him, then he dies, and then she instantly regrets rejecting him, and then in turn she dies as well. So it's kind of like a twist on Romeo and Juliet. I think so. Like, you can obviously find some similarities and obviously not similarities, but she rejects him, and then he dies. She regrets it, and then she dies later on. Just a little popular folk ballad. Look up at page 15, Get Up and Bar the Door. Same thing, this is also a ballad. Get Up and Bar the Door, it fell about the time, Martinmas time. So if you guys look at that page, on page 15, the first line, it says, it fell about Martinmas time. That's referring to St. Martin's Day. So if you guys look on page 14, that definition, Martinmas, November 11th, St. Martin's Day. This story is basically about a man. He asks his wife to close the door because it's cold. She's busy with the housework, and so she's like, no, do it yourself, or she refuses. And then they make a bet with each other how they're not going to talk, and then if someone talks first, then they have to go and close the door. Well, while she goes about her chores and prepares food, and while they're not talking to each other, two strangers come in, and they ask for shelter, they eat their food, and then they go to the wife and say, let's, shave your man, and then can I kiss you, basically. He wanted to kiss the wife and then shave the man, and then obviously the man's like, what in the world? That's not going to happen. He talks first, and then the wife is basically like, ha, you talked, go close the door. So stupid stories that, have a little or none meaning, have little to none meaning, but they're popular stories back then, okay? And then on page 16, The Cherry Tree Carol. This is a carol because it's pertaining to religious works, like we said. So carols were originally joyous songs or hymns, but became carols and associated with Christmas hymns. And then this basically is talking about the, if you guys look at number 4, the fundamental doctrines of Christianity. So if you guys look at throughout, it talks about Jesus being born of a virgin, and then Jesus is God and has power over creation. And then the last doctrine it talks about is that Jesus would die and rise again. If you guys look in lines or stanza 5, it says, "O then bespoke Joseph with words most unkind, let him pluck thee a cherry and brought thee with child." It's basically Joseph talking to Mary. We know that Mary was a virgin when she brought forth Jesus. And then in lines 21, "O then bespoke the babe within his mother's womb, bow down then the tallest tree for my mother to have some." So he's telling the tree to bow down, and so we know that Jesus Christ has the power over creation and over the universe. And then the third one we see is in line 41, "O I shall be as dead, mother, as the stones in the wall, O the stones in the streets, mother, shall mourn for me all." Basically, that's talking about that Jesus would die, and then the next stanza talks about when he would rise again. "Upon Easter day, mother, my uprising shall be." So this is a ballad or a carol talking about some of the three fundamental doctrines of Christianity, okay? And then the last one is the Cuckoo Song. This just celebrates the return of spring. You can see the translation from Old English to the modern translation. So that's just something for you to read, but that's there to show you what it was written back then, okay? All right, we're good with literature. I want you guys to go ahead and prepare. For those of you who are retaking your quiz, we're going to retake that in a second, but let's review. Oh, there's my husband. Sorry. Sorry, I'm changing my my PowerPoints, okay? So let's review really quickly. Make sure you guys know what goes with a direct object, an indirect object, and a predicate objective complement. Make sure you guys know that goes with an action verb. Make sure you guys know what a linking verb goes with. That goes with a predicate nominative and then a predicate adjective. Make sure you guys know what an indirect object is. You ask to whom or for whom. Okay? We know that complements complete the meaning of a sentence. When you're finding a DO, an IO, and an OC, you find the action verb. Then you find the subject. You ask who or what did the action, and that would be your subject. So after you find the subject and the verb, you would ask who or what, or she did who, whom, or what. Okay? So what would be your direct object? To whom or for whom would be your next question after you found your direct object. And then to find your objective of the complement, you would say, she made him, and then you would ask to be what? And then that answer would be your objective complement. All right? To find objective complements, you find the subject, the verb, the direct object, and then you ask to be. Finding PNs and PAs. Predicate nominatives were names of subjects. Predicate adjectives describe the subject. Remember that. First, you find the linking verb. Remember that there are certain verbs that are always linking, and then there are some linking and action verbs. So make sure you guys are looking for the use in that sentence. You find the linking verb, then you find the subject, and then you ask who, whom, or what after the verb. And then whatever renames the subject or whatever describes the subject is your predicate nominative or predicate adjective. Okay, go ahead and prepare for a quiz, and then I will be right over there. For those of you who haven't sent me your quiz yet on distance learning, please email that today, and then tomorrow when you guys come in to pick up your books and your papers for next week, you can turn in the actual paper with that, okay? If you guys have any questions, let me know. Oh, quickly for homework, just to review, grammar, page 6, exercise 11 and 12. Page 6, we're going to talk about parts of speech. So go ahead and fill those out, and then we'll discuss parts of speech tomorrow. And then literature, page 17 through 22, read that. We're going to discuss that in class. And then page 12, in your vocab, exercise C, which is the roots, the prefixes, and the suffixes. Alrighty, thank you very much.
All right, welcome to Algebra 2. Looks like everything's working okay. Let's pull that. No, you're not going to work with me. Okay. I'm going to do this then, because it's going to bug me. All right, we are in chapter 1. Sorry, we're on 1.4. We're still dealing with some basic algebra. And so we're on 1.4. This is going to be over 2 days. Today we're going to deal with the first half. Tomorrow will be the second half. But factoring special form polynomials. Okay, so we're going to get into general factoring. I believe that's the next section. Okay, so we've already kind of talked about division, which is an important step about factoring. And then we're going to work on factoring special form polynomials first. We're going to teach you guys the shortcuts, and then oh my word. Then we'll teach you guys the long way in case the shortcut doesn't work, okay, or there isn't one available. So let's get right into this, okay? The fundamental theorem of arithmetic states that every composite number can be written uniquely as the product of prime factors. So we've dealt with that. So for example, 12, okay, we can factor that as 2 times 2 times 3, and that's the only way we can get it factored. The only way we can simplify is to do 2 squared times 3. Past that, it will always be that. Well, we can do the same thing with polynomials, okay? They can be written as a product of prime polynomial factors. A prime polynomial is a polynomial that can be factored no further. Now, a prime polynomial can be split into 2 categories depending on the type. Depending on the type of the numbers desired for its coefficients. The first category of prime polynomials is prime over the integers. That means it's a polynomial that cannot be factored into 2 binomials with integer coefficients. For example, the binomial x squared minus 5 would be an example of this because it can be factored. We would get x plus the square root of 5 times x minus the square root of 5, but that's not an integer. Okay, so that would be prime over the integers because that uses factors that are not integers to factor it. The second category is prime over the real numbers. A polynomial that is prime over the real numbers cannot be factored using either rational or irrational coefficients. For example, the polynomial x squared plus 4 cannot be factored because that's it. I don't know how to explain that. X squared plus 4 can only be factored outside the real number system, to use complex numbers, to use imaginary numbers. We'll talk about that later this year. Okay, but for right now, we can't do that. So all problems in this section will require only integer coefficients to factor. Problems will not require answers that contain radical values. This section only. All right, so common factors. 3 general methods are used to factor polynomials: special forms, trinomial forms using FOIL, and grouping. Give me just a moment. Okay, someone moved around all the scenes on me. That's fun. All right. Here we go. Back to Algebra 2. Sorry about that. Had a computer freeze on campus. All right, so. Right, prime polynomial is a polynomial that can be factored no further. And so we're going to be using one of three ways or fourth way, but anyway. Special forms, which is what we're going to talk about in this section. Trinomial forms using FOIL and grouping. General factoring forms can be difficult to identify if common factors are present in the polynomial, so that's always step one, is to remove the common factor. So step one is to pull out or factor out any common factors that appear in a polynomial. So for example, with 3r plus 6, well, we have a common 3. So we're going to pull that out first. So we get 3 times r plus 2. Now, that may be all you can do, and that's fine. Okay, that's still factoring. Okay, in example B, okay, just making sure, we are given 12q cubed, that's fun, minus 24q squared. Okay, so I have a couple common factors. The first common factor I have is 12. We have 12 in both numbers. So I can factor out that 12, but then I also have q squared, because there's a q squared inside q cubed. Oh, thank goodness I don't have to say that again. All right, so q squared, okay? And so this leaves us with q over here, because it's all that's left when we divide by 12q squared. And when we divide this one by 12q squared, all I get is negative 2. And so we've pulled out everything that's there. That's it, we're done. Okay, so that was example A, part B. Part C, we have 12x times m plus 2 minus 5 times m plus 2. Okay, and sure, that was a great straight line. All right, now here it looks at first glance like there's not a common factor, except inside the parentheses is common. We have a common factor of m plus 2, so we can factor that out. So we have is equal to m plus 2 times 12x minus 5. And so that allows us to factor that out, and now this is done. All right, so that's a very convenient thing. Now we're going to, first, two things to notice in this example. First, each factored form can be multiplied to obtain the original polynomial. This process provides an easy way to check that the factored form is correct. Second, the common factor that is removed from the polynomial remains as a factor. A common mistake is to simply drop the common factor, but that is incorrect. For example, when factoring 14, both 2 and 7 would be written in the final answer. Just writing 7 would be incorrect. Okay, so just like that, we can't drop anything. We can just pull it out. Okay, and it stays there. It factors out, but that's as much as we can do. All right, so special forms then. We're going to look at, first of all, a perfect square trinomial. Now, we're only going to look at perfect square trinomials for now and common factors. Okay, those are the two things we're going to really hammer on today. And then we'll look at some other special forms. But we're going to look at perfect square trinomial. And it's an important form to recognize. Okay, so there is a check to see if something is a perfect square trinomial. Now, before we get into that, remember that a perfect square trinomial must be in the form of a squared plus 2ab plus b squared. Okay, that's what a perfect square trinomial will look like. Now, your book gives a more general form because that's showing you how to factor, but that's what a perfect square trinomial should look like. Okay, and so we're going to check a few things. The first and last terms need to be perfect squares. Okay, unfortunately, my drawing is not going to last because it's every animation is actually its own page and it's a PDF file. But anyway, but the first and last terms are perfect squares. Okay, if they're not perfect squares, you don't have a perfect square trinomial. So if you have a 3, well, that's not a perfect square, but if you have 9, that works. Okay, anything where you can take the square root without anything left over. The last term sign has to be positive. Okay, if the last term sign isn't positive, you do not have a perfect square trinomial. And then finally, the middle term has to be 2 times the square roots of the first and last term. Okay, so we'll go through and double check. The book has a whole different check, but if you just look at it, you should be able to tell. So then we can factor. Okay, so step 1 is check, make sure. Step 2 is to factor. This is the way the book puts it. Notice again, we have the first and last terms are perfect squares. Okay, they may or may not show a square, but as long as they are perfect squares, we're good. The last term sign has to be positive. You'll notice I don't have it shown as plus minus here. Okay, it has to be positive. And then plus minus here, this plus minus determines this plus minus. Okay, this sign, this first one that you'll hit, determines the sign inside the binomial. Your first term has to be positive, and I forgot to write that. First and last term. Okay, your first and last term have to be positive. Now we're going to write our parentheses squared. That's step 1. Okay, so if I was just given the left side, then we write the square root of both the first and last terms, and we use the sign of the middle term of the trinomial. So you have 2 steps. First one is to check, this was 3, and then when you actually go to do, you just use the shortcut. So okay, that's the next thing. So let's go to example 1.4b. Okay, example 1.4b. And what we have here, let's see here, this is example 1.4b. We're looking at part A. So we have 25x squared minus 20x plus 4. So let's run through our checklist. Okay, I checked the signs first. I know it's kind of out of order from the slides, but first of all, I checked the signs. Are my first and last terms positive? Yes. Are they perfect squares? Well, let's look at this. 25x squared. Well, x squared is a perfect square. 25 is a perfect square. We're good. 4, perfect square. Yep, cool. And finally, the middle has to be double the square root of the first and last. Well, the square root of the first is 5x. Square root of the last is 2. So 2 times 5x is 10x. Double that is 20x. Sweet, we're set. So now I'm going to go through and factor. Okay, so I'm going to write my parentheses squared. I'm going to use the second sign. And then I'm going to take the square root. So 5x and 2. So 5x minus 2 squared, that is this thing factored. Okay, you'll notice most of our work is actually checking to make sure that this is in fact a perfect square trinomial. The actual factoring is very simple. Okay, almost too simple to where it starts tripping people up for other types of trinomials. This is why we have to check that it's a perfect square trinomial, because if it's not, it won't work. In B, now of course most of these will pass the test because we're in the perfect square trinomial section. It'd be kind of weird if they didn't, but just mentioning we need to get in the habit of checking, because soon, and I mean soon, we're going to start getting a mix of problems, so you have to make sure you're paying attention to it. So part B, we have 4x squared plus 12xy plus 9y squared. Okay, so the first step is to check for common factors, and I forgot to do that in part A, but there weren't any. And again, there's none here because 4 is not divisible by 3, 9 is not an even number. That's it. Okay, there's no common factors, but that's always step 1. Check for common factors. Okay, step 2, check if it's a perfect square trinomial. All right, well, my first and last terms are positive. Sweet. First and last terms are perfect squares. Great. 2x times 3y, and when we take the square roots, becomes 6xy. Double that, we get 12xy. That matches. So that means I can go ahead and use the shortcut. So we're going to do equals, parentheses squared, the square root of the first, using the second sign, plus the square root of the second, 3y. So 2x plus 3y squared. Again, it's very quick once you've done the check. You have to do the check. You cannot skip it. Okay, because there are plenty of these things that are not going to be factorable. If not in this section, in future sections. There it is. All right, part C. We have x squared plus 2x times x plus y plus x plus y squared. Okay, first of all, it's very clear we have squares on the first and last terms. They're both positive. It's very clear that the center is double the square roots. It passes the test. So what I'm going to do is I'm going to actually set a bracket squared, because we have parentheses as one of our factors. Okay, but this is perfectly allowed. Okay, you can have parentheses in here. So I'm going to take the second sign and I'm going to put it in. We have x as our square root of the first term. Square root of this term would just be x plus y. Now, I'm actually not done. It's my job to simplify as much as humanly possible. So, without undoing the factoring. So, then we have, I'm double checking that I'm not doing this weird. Yeah, that's right. Okay. Now, obviously this plus in front of these parentheses isn't doing anything. As far as like when we distribute plus 1 to everything inside, everything stays the same. So we're going to just simplify this to 2x plus y squared. Okay, and that's our final answer for C. For part D, we're going to do the same idea. We have x to the fourth plus 2x squared y squared plus y to the fourth. Okay, well, things here, this almost is perfectly the definition, except all my powers are double what they should be. Well, then that's fine. Now, if I take the square root, I'll get x squared. So this passes all our tests. We've checked that. And so what we're going to do is we're going to take x squared plus y squared, because those are the square roots. Our second sign is positive, and that's squared. Now, the temptation might be to try to factor this further, but you cannot factor the addition of even powers. Okay, and that's something we'll talk about in a future thing. All right, that's as far as we're going to go today. So we talked about factoring out common factors and factoring out perfect square trinomials. Again, the key here is to remember your test. Okay, remember your test for your perfect square trinomials. And then again, we can go back through and factor out common factors first. So you guys right now, let me write this out on here. Okay, classwork is practice 1.4 green for numbers 1 through 30. Okay, there's not a lot in there, but I want you guys to get some practice before you guys are done today. Okay, so we're going to do that. And then your homework is review 1.4 green, and that's all of them. Okay, all the greens. It is quite a few questions. However, yeah, let's do that. This one will be due Monday. I will have to fix that in Google Classroom, but this one will be due Monday, so you guys have 2 days to do it. Because it is a little longer of a section, and we're in 1.4 for 2 days anyway. So your homework is to do review 1.4 green. That's due Monday. On this one in particular, actually, let me go ahead and fix the assignment now while I'm thinking about it. This assignment in particular, you guys are going to do this a little differently. Normally, I have a place for you guys to fill in a form. I just want you guys to take a picture and put it on the assignment. Normally, I'll have a form for you guys to fill in answers. But due to life, I was out yesterday, you guys know that, I haven't been able to put them in. So you guys are just going to be putting in a picture. So let me go through and edit this. All right, so this is due on Monday. I'm changing the date it shows on Classroom right now. All right, so this is due on Monday. I highly recommend at least getting like half of it done tonight, or you guys are going to have a lot of homework this weekend. So that's what you guys are doing. We'll finish 1.4 tomorrow, Lord willing, and I will see you guys later. Have a great day. Make sure you guys get your practice in. All right, welcome to Pre-Calculus. We're on 2.2 cofunctions. Please make sure you're on page 15 of your textbook. Page 15 of your textbook. We're in 2.2 dealing with cofunctions today. Well, cofunction is simply just an abbreviation for complementary function. And so what this means is complementary, remember, means you add it up to 90 degrees. Okay, no, that's not happening. Complementary means you're going up to, or it with another angle, goes up to 90 degrees. And so you may have noticed that a lot of our names sound familiar. We just put co in front of them. So sine and cosine, tangent and cotangent, secant and cosecant. That's because if you look at the complementary angle in that right triangle, then things are exactly backwards. They're complementary. So the sine of A will equal the cosine of B. The cosine of A will equal the sine of B, assuming we're in a right triangle. The tangent of A will equal the cotangent of B. Cotangent of A equals the tangent of B. The secant of A equals the cosecant of B. Cosecant of A equals the secant of B, because again, that's what the whole idea of cofunctions. If you ever need to convert from one function to another, for example, I need to use cosine for some reason. Okay, it actually does come up later, where the sine of A is equal to the cosine of 90 degrees minus A, again, because that's what B would equal in a right triangle. Okay, so those are all the forms that there in your textbook on page 15. Let's look at example 1. Example 1, write in terms of the appropriate cofunction, the sine of 28. Well, in terms of the appropriate cofunction, well, we have the sine of 28, then it's going to equal to the cosine of 90 minus 28, which is going to equal the cosine of 62 degrees. Okay, because all we do is just subtract. For the cotangent, if I want to get this into tangent, okay, which can be convenient, we just do 90 minus 42, and we get the tangent of 48 degrees. Okay, so it's pretty easy to convert them back and forth between cofunctions. And then, in example 2, we're asked to solve for A in this equation. Well, the easiest way is we're going to do this is we're going to go ahead and convert sine to cosine. And so the cosine then will be of 90 degrees minus A plus 15 degrees. Okay? So that negative just needs to be distributed, so we end up with 90 minus A minus 15. And so we're going to get the cosine of 75 degrees minus A. Well, if my cosines are equal, then the stuff inside my cosines are equal. So we can just drop cosine from both sides. And we end up with 75 minus A is equal to 2A. Okay, so let's get all the A's by themselves. We're going to add A to both sides. So we get 75 degrees equals 3A, which means then that A is equal to 75 divided by 3, or 25 degrees. All right, so this is fairly simple. This is an application of where we would need cosine instead of sine there in that left side. So those are your two examples. Today's work is you're going to do exercises 2.2 evens. 2.2 evens. Please do not do all of them. 2.2 evens only. Okay? So there you go. 2.2 evens. That gives you 25 questions. It shouldn't be a ton of subparts this time. And that'll be it. I'll see you guys. Oh, real quick, one more thing. Okay, 2.2 evens. And then you guys have quiz 3 over 2.1 through 2.2 tomorrow. Quiz 3, 2.1 through 2.2 tomorrow. All right, I'll see you guys later.